Hello, I am going to talk to you today about dividing polynomials using long division. Before I start though, I want to give you a little long division reminder. You probably haven't seen this for quite a while, so I just want to remind you that when you are taking something like 460 divided by 3, you can use long division. In order to use long division, we put the number we're dividing by outside this little house and the number we're dividing inside. So the only thing we care about is the first term here. So we need to look, how many times does 3 go into 4? Well, I can put 3 into 4 one time. Then I take whatever number is up top here and multiply it by the number out here. So 1 times 3 is 3. I change the sign and then I add. 4 plus negative 3 is 1. Then 3 does not, then my first term is now down here. But 3 doesn't go into 1, so I have to bring down my next number. How many times does 3 go into 16? Well, 3 goes into 16 5 times. Now I take this next term up here and multiply it by 3, and I get 15. Again, change the signs and add. 16 plus negative 15 is 1. 3 doesn't go into 1, so I bring down my 0. Again, this first thing is all, this number down here is all I'm worried about. How many times does 3 go into 10? 3 times. 3 times 3 is 9. Change the signs and add, and I have a remainder of 1. And when you were in elementary school, you probably just wrote R1. That's not okay for us in high school. What we are going to do is write the remainder, and then it's the only thing that hasn't been divided by 3, so we put it over what we divided by out here. Now that's with numbers, it's not too terrible. When it gets to be polynomials, there's a little bit more going on. So we have to keep a few things in mind before we start. When you're dividing polynomials by long division, the first thing you need to do is make sure that all the polynomials are in standard form, meaning that you start with your highest degree and you work your way down by 1 until you get to your constant. That's the number without a variable. The second thing we need to do is make sure that we have a term for all of the exponents in our standard form, which remember is in decreasing order, and we need to put in a 0 as a placeholder for any missing terms. This is a very important step. If you forget this step, your answer will be way wrong. So if we look at this polynomial is not in it is in standard form because it's decreasing, but what's the problem with it? I have x to the 4th, x to the 3rd, and then no x's. What am I missing? I'm missing an x squared term and an x term. So if I were going to write this and set it up for polynomial long division, I would bring down these first two terms, 4, 3, and then I would need to put in a 0 for my x squared term and a 0 for my x term, and then bring down my constant. See, now I have 4, 3, 2, x to the first, and no x's, in decreasing order with a term for all exponents. We need to make sure that's going on or we won't have the correct answer. So let's get into this. For example, if we take 4x to the second plus 3x to the third plus 10, and we are trying to divide it by x minus 2. Well, what are we trying to divide? That goes in the house, and what we're trying to divide by goes out front. So x minus 2 is going to go out front, and up here, this goes in here, but remember it has to be in standard form and we need placeholders. So our first term, our term with the highest degree, is 3x to the third. And then next should come our x squared term, which we have one, 4x squared. Do we have an x term? No, so we put in a 0 as a placeholder, and then we have a 10. So 3, 2, 1, and my constant. So I've got all my terms. Now I'm ready to start. So the first thing I do is I ask myself this question. We are, again, only dealing with this first term, and as we work our way down, we'll only be dealing with the first term. So 3x to the third is what I'm trying to get. And I have to multiply something up here times x to get that. So I ask myself this question. What times x, because that's what's right here, gives me 3x to the third? Well, I break it up into numbers and then I do my variables. So what times 1 gives me 3? That's 3. no, I don't have any x's so far here, so I need to figure out how many x's I need. I have x to the third. I only have one x here, so I will need x squared to get me to that 3 x's, because 2 plus this 1 would give me 3. Then we have to multiply this number up here times both of these. So I write it over here so I don't forget. Oops, there's no 5. 3x squared times x minus 2. And we're going to put that right here. So 3x squared times x is 3x to the third. 3x squared times negative 2 is negative 6x squared. Then we're going to change our signs and add. So you might write yourself a little note. Change signs and add. So 3x to the third minus 3x to the third gives me nothing, so I don't have to write it. 4x squared plus 6x squared gives me 10x squared. And then I have 2 terms out here that I'm dividing by, so I need 2 terms down here. So I'm going to drop down this 0x. And then again, all I'm worried about is this first term times x. So I need to look, what times x gives me 10x squared? So what times 1 gives me 10? 10. What times x gives me x squared? X. And then I write it over here so I don't forget to distribute to both terms. You don't have to do this step over here if you don't need it, but I do it so I don't forget to distribute to both terms. So 10x times x is 10x squared. 10x times negative 2 is negative 20x. And then again, I'm going to change my signs and add. So 10x squared minus 10x squared gives me nothing, so I don't have to write anything there. 0x plus 20x gives me 20x. And I'm dividing by a binomial, so I need 2 terms here, so I'm going to have to bring down my plus 10. Next, I think to myself, all right, what times x gives me 20x? Notice again, only that first term we're worried about, and only this x. This 2 just kind of comes along for the ride. So what times x gives me 20x? Again, break it into numbers. What times 1 gives me 20? 20. What times x gives me x? I already have the x, so I don't need anything else. Write it out here so you don't forget to distribute. And put that over here. So 20 times x gives me 20x. 20 times negative 2 is negative 40. I hope you remembered that we needed to change our signs and add now. So I'm going to change this sign and this sign. Remember, you change both of those signs here. When I add 20x minus 20x, I get 0. And when I add 10 plus 40, I get 50. So there's nothing else to bring down, so this is my remainder. But remember, instead of writing R50 like you would have done in elementary school, we are going to take this back up here. And remember, this is the only thing that hasn't been divided by my divisor, so I'm going to make it a fraction with the divisor. Let's try another one. If I have 3x to the fifth minus 28x to the third plus 10 plus 17x to the fourth minus 9x, and I'm dividing that by 3x minus 4. Well, the first thing I'm going to do is set up my little division sign. Remember, my 3x minus 4 goes out here, and this needs to go under in standard form. So the first thing is 3x to the fifth. Now my x to the fourth term, 17x to the fourth. Now my x to the third term, and now my x squared. I don't have an x squared, so 0 is my placeholder, minus 9x plus 10. This is going to be a long one. So remember the questions we think to ourselves. We think, what times 3x gives me 3x to the fifth? So what up here times 3x gives me 3x to the fifth? Well, what times 3 gives you 3? 1. We need x to the fifth. We only have x to the fourth. or we only have one x, so we will need x to the fourth. So x to the fourth times 3x minus 4. And again, you don't have to do this step out here if it confuses you. So we've got 3x to the fifth minus 3 times negative 4, negative 4x to the fourth. Then we change our signs and add. That cancels, and we've got 17 plus 4, so 21x to the fourth. What times 3x gives me, oh, we need two terms down here, don't we? I'm sure you noticed that and remembered to bring this down. Now we think to ourselves, what times 3x gives me 21? Well, what times 3 gives me 21? 7. And what times x gives me x to the fourth? X to the third. So 7x to the third times 3x minus 4. And that's going to go over here. So 7x to the third times 3x is going to give me 21x to the fourth. 7x to the third times negative 4 is going to give me negative 28x to the third. So I change my signs and add. That cancels. Everything canceled. Well, but I still have more up here that needs to be divided. So I'll start bringing these things down and kind of start keep dividing. So if I bring down 0, that's not going to help me. So I'm going to bring down my next term of substance, which is negative 9x. And remember, I do need two terms, so I'm going to bring down this 10 as well. So what times 3x gives me negative 9x? What times 3 gives me negative 9? Well, negative 3. So negative 3 times 3x minus 4. Negative 3 times 3x is negative 9x. Negative 3 times negative 4 is positive 12. Then I need to change my signs and add. So make those different. That cancels, and this gives me negative 2. So I have a remainder of negative 2. So I put it up top, and remember it still needs to get divided by 3x minus 4 because it's the only thing that hasn't been. One last thing, let's see if I have time. If you are dividing by a monomial instead of a binomial, so there's my polynomial, and it's being divided by this monomial, we can just look for GCFs. So if you look at the numbers, 3, 6, 12, and 15, those can all be divided by 3. Then I look at my x's. X to the third, x to the second, x to the second, and x to the fifth. What's the smallest number of x's? X to the second. Then you look at your y's. What's the smallest number of y's? Y to the third. So I'm going to divide every one of these terms by this GCF. 3 divided by 3 gives me 1. X to the third divided by x squared gives me x, because remember you subtract exponents. Y to the third divided by y to the third gives me nothing. 6 divided by 3 is 2. X squared divided by x squared is nothing, because you subtract. Y to the fifth minus y to the third is y to the second. Then 12 divided by 3 is 4. X to the second divided by x to the second is nothing. Y to the sixth divided by y to the third is y to the third. Over 15 divided by 3 is 5. X to the fifth divided by x squared is x5 minus 2 to the third. Y to the fourth would be y to the first, because 4 minus 3 is 1. So you divide the numbers just like normal, and remember you subtract the exponents. Now I look here again. 1, 2, 4, and 5. Can those all be divided by any number? No. Do all the terms have an x? No. Do all the terms have at least one y? No. So there is no greatest common factor for all of these terms, meaning this is my answer. So now you've seen dividing by a binomial and dividing by a monomial. Good luck with your long division.